hardware, software, and this will switch from the general overview of the equipment component to a particular tool, or perhaps tools, because we have two sessions right now. The first session is about database query. Martin already mentioned or touched it in the overview presentation. And he also already said that it's not fully new tool. This is a tool that was released here from version 4, 14, actually, but there are significant enhancements now. But first I should ask you, who of you is using database query? Maybe I can adjust them. So I hope
in external database, so we are doing external. So simply we export the data to the external database and then we do it.
Because it's difficult to find the proper level of explanation for those who are using it. It's like my presentation might be too boring because you know like more of the functionality already. For those who are new to field might be confusing speaking about this particular tool. So anyway, I will start with simple thing. What is it good for? So obviously, it's called database query tool, so it enables querying to human database. And now, right now, at the very beginning, I will try to sit you a bit to explain for those who are new to human. Where are we now, or to put it into context? Because you might remember that we have a database, we have a query builder in Figma. You can put queries, or you use queries in data processing tools, so why should we not need another query tool? So I would put this DQT into Figma data management and data processing tools family. And unlike these tools listed here, it can or enables you to create more complex queries. So it enables complex data selection. And the good thing is that it doesn't require SQL knowledge. You just have to be familiar with SQL. So on one side, it enables you to query database. On the other side, it enables you saving query results into Excel files. So you can output your queries. And it enables you saving your queries to Navigator, so it can be used to find problems, inconsistencies in data, and so on. What DQT does not enable is changing data. So however it is enabled to query your data, it doesn't change your data. It only produces outputs, but it doesn't change and touch your data. Basically, there are three ways how to run. The first possibility is that you can use a tool just as a single executable outside Figma. It's available in your tools, Figma tools. Then you can use DQT directly from Figma data collector. And you can even call it through the scripting function. The third possibility might be handy in case you need to calculate something before you run this tool. Then you first do your calculations and then come to DQT. If you are running EQT in FieldMap data collector, then you always have a possibility to activate it or deactivate it through the FieldMap project manager. I see some faces you don't understand, so I will show you later when we are. And actually, this is last slide from my presentation because then I will move to real examples. There are few steps to build a query. So the steps are: first, you set up a task. Then you select attributes that you want to attribute. Then you might apply conditions. You can check your SQL, and then you inspect your results. So basically, that's all for the overview. So now we can move to real examples. If you don't mind, I will sit down so that I can type. So from the set of possibilities of the RAP I chose the possibility to run it in FieldMap, and we have this is the example project that you installed with FieldMap normally, so you might know it. You might be familiar with this project. I think other my colleagues will also use the same project for examples. However, I had to slightly change it or adding some layers to show you the difficulty in all the context functions. Anyway, so this is how to run it. Database for it, and here is some database for it. So this is the way we know. So first step is to define a task. You can see I already to define. For those who know FieldMap already, this might be familiar for you. These buttons enable you to organize your tasks into groups so that you know where to choose. And these ones show the steps I showed on the slide. Selection of attributes, defining conditions, give you SQL, and see the results. So let's try to make a task from scratch. So I will add a task. I can name my task. I can name it to, let's say, test task. And one of the so what should we define? Let's start from the more simple things, just to overview what we have in the database. So let's focus on these. Okay, so let's move to a selection step. And what you see here is a list of all available attributes in your project. If you remember correctly what I said that EQT can do for you, that it can query your FieldMap database. The FieldMap database, this is important that it's a FieldMap database because as you can see, it keeps the hierarchy of your project. If you use, for those who are using, for instance, Access for querying, or you have just number of tables that are not connected. This way, you can see all the connections here. It keeps so it's then this is then much easier to make queries. You can very easily list all attributes within each layer. And so, as I said, for the first query, we will do the most simple thing. So let's see what we have here in trees. So we might be interested in plot ID, let's say tree ID, DBH, height, and maybe species. And here in species, I can demonstrate another advantage of this tool, because for many attributes we use those lookup lists. And if you use access or if you use other queries, you have to join. If you want to have an overview of, for instance, species, you will have to join two tables, join these tables, and join your lookup list. Here, you have all in one. So all those attributes that are listed in this LKP are already your species, for instance, in this. So the result of lookup list. So this is very easy and the most simple thing we can do. Let's move to conditions. Again, this is the most simple example. So now we have three choices here. Either we can limit selection to just to one plot, the one that is open, or we might want to ask or to query the whole database. And we have another option of date limit. This is probably not the case for now, so let's leave it like it is. Another step is SQL preview, and this is only preview. This only shows you how the SQL would look like, but you can't change it here. This is just to check on it. And this is, now we are in the result. So we can see this is the list of all trees in our database. And this is a very simple statistics. So we have 237 trees in our database. We can play a bit with these column captions. We can either use just labels, or we can use combination of layer and labels and so on. And now we have two options. We can save the file to Excel. So let's save it. This table location, save, and it is saved in this nice way. Very easy. We could also save it to Navigator, but it wouldn't make much sense to do it for the whole database. So let's change a bit this example. We can go back to conditions. We might be interested in trees that have missing DBH or height, perhaps. So in this case, we will add more conditions. And we can do it.
Maybe you can choose also some specific species, like, but there is only one species here.
No, there are some more.
So maybe each is missing a
Yes. So we might be interested in the condition might be that we want list all trees with that species is. I think that mostly we have this one.
Check one.
Tam je nejvíce tam. And we can add one more condition, and we won't list, or we won't see all trees with missing DBH. It means DBH is moved. So this condition says, okay, I am interested in Subatica and DBH is moved. Let's see if we have some trees like this. If we have a look at this SQL, this is more or less the same, and this is the condition here. And this is the result, and we don't have any things like this, but I'm pretty sure that if we change it for height, there will be some. Yes. So now we have the option to save it to Navigator. Give me Navigator file within height. Or DBH. So DBH. Right? And save it. And now, this is the navigator that navigates us within the database, so we can easily check then our project. Not correct.
This is just for one plot.
Not necessarily.
Not necessarily.
In this case.
In this case, so let's adjust it. It is we don't have a condition for limited purpose, but this is what I normally in one plot.
Yeah.
So if I skip this, easy to skip, or if I change it for, so we have, I don't remember what. Let's try this one. Yes, there are some other plots.
Yeah, all the plots.
If it is from more plots, you will get them classified into groups by plot, and then if you click to anyone, it will go to the respective plot, and will address the record which is there.
Yes, let's. If I skip the condition, the species condition, then it will show. No. Yeah. No. No.
Checkboxes are there just for you. You can check those which you already visited and corrected, and then you have at the bottom you have the possibility to delete those which are checked. So you can gradually shorten the list of those problems, for instance. That's the only thing.
To check some values, some mistake, for example, I want to check DBH less than 9 because this is a mistake. Is better to use this method that Martina showed? What about the other method? Is this query tool directly in this tree layer? You have also a query tool. Is the same? Is different?
I believe that this one is much more powerful because it goes across more plots and it gives you a navigator. But the result is the same, of course.
The other one is just for the plot that you have.
Yes, so this one is, and you can repeatedly open it because the navigator file will stay there. It's saved, unless you delete it.
So maybe I wanted to show you later that we touched the metal now. So, as well as the navigator file is saved within the project, the queries are also, the tasks are also saved within the project. So maybe this, now, the time to show you where or how is it saved. So this is my project, this example project. You go now to this directory with the very important general settings, and there is a database query tool of navigator directories, and so these are the XML files which defines the result of the navigator, and well as the database query tools, and these XML files that define your queries. So
So Martina is right. First of all, the queries, tasks are stored automatically for future recall. Secondly, the queries can be much more complex than those ones which you would type as a filter. Yeah, the query builder, but it's filtering. So these are probably the two main reasons why
so this is our task stored within the XML file, and it's human readable easily. This is the selection, so we chose to select IDs of plots of trees, DPH, height, and species, and we have a very simple condition. We have no date limit, and that's it. This is just for your information. But within this database query tool, you see we have, one, two. I have 3 XML files. So what does it mean? We distinguish synchronized or general tasks and local tasks. So for those who use synchronization, you can also synchronize your tasks. But you might have your tasks or your queries that you don't want to be synchronized. Then that's why we distinguish these two. And if I go back to the which is here, this is how to distinguish. You see synchronized tasks, or we can switch to local tasks. I don't have any here. I use this global tasks. So let's go back to our example. So you already noticed that we have combined our conditions. We can even use brackets if we want to build more complex queries, or we can and we can use either or and.
Because usually these query builders is only and. We have also or. And if you have or, you must have parentheses. That's why we have it here. So you really can combine conditions in different levels and grouped by parentheses, yes, and this relation and or.
So example might be you are interested in trees with height. I'm sorry, because I want to combine, so first I should put parentheses. So this is and okay, maybe I'm sorry, one more mistake. First condition might be our species condition. Species is something. This one. And if now I want to use or to condition this or, so then I use brackets or parentheses with let's say EPH is null, or height is known. So this is more complex condition with the kids. We can overread. You can see here. This is the condition, and this is the result. In this case, this is the same as first one with the method of data.
Ale to tu, že to nachodám tady v tom.
To jsem chtěla.
Dobře.
And we have also other option. We can prepare a query with what we can call a dynamic query. If I use here question mark for lookup list, and I run this query, then I can choose now in which species I am interested.
In runtime.
In runtime, yes, like this. So like
That's how developer of the project can prepare tasks for the for the colleagues. I mean, it's out at least. Not fully predetermined.
and we can have many more conditions here. So again, we could add maybe
Bude větší než třeba něco?
yeah, so we can put a limit here, let's say 500 or so. Yeah. So this is, and if you predefine task class this, I mean this dynamic runtime condition for your colleagues that are not familiar with this query, and you can even switch off this edit mode, and you can present, or they can work just with the, let's say, limited version of this tool, and they would then have only the task and the result, and that's it. They would do that for themselves with conditions and selections. So I think basically it might be the overview. Ah, yeah. There's some more. Of course, there's some more. Let's move to a bit more. Because other option, now we only listed attributes, but we can use also aggregations, and we can order our output. So let's change. I have prepared something that So I could use this example of maybe two examples. One is very simple, the other one is more complex. We might be interested in mean diameter. So we might be interested only in the relevant attributes are only plot ID and PPH, and we might be interested in the average. So the average is, I just click this average and that's it, like this. But I want to.
Plot ID is grouping attribute.
Yeah, this is. I wanted to group. I must group it. So then I put this group into plot ID because we want to have it grouped by IDs. And probably it's good to put a condition that DPH is not null, so that it's calculated correctly. And this is the result, and so this is the result, this is the average per plot.
Can you separate it by species?
Of course I can. Then we would put species here. Probably we would move the species here because you want to group it by species. We say okay, group it by species, group, and that's it. We have five species. Yeah? So this is
You could put as a new column average count of trees or
of course. Count of trees.
this is the count of trees. Some of the ID, yes, of the trees. Or no?
You want count?
Count,
Yeah,
count,
yes.
count.
Count of trees, to má ten count je tam vždycky automaticky. Když až select trees, tak to máš ten count.
No, jestli to je to,
Je normálně select.
no to by muselo být jako zvláštní.
You don't have a statistics of count here. Yeah? You have count here automatically always.
Yeah,
So
okay.
if you select,
If you count of groups, so if yeah, we can select.
Count the names.
This is
yes,
a,
yeah.
this is a just list of trees. So automatically your count of trees.
But if you want
But it's not by tree, by plots.
count of
Not by species.
Okay, so if it is necessary, if someone would like to have a statistic of count, if you go to selection, so we will add together with those which we have some average. We can add count.
I think I already searched for it as well before.
Yeah.
The count,
Okay.
sometimes it's quite easy to
Yeah.
have an idea.
Okay.
Yeah. Yeah.
What
I don't know how much effort it's. It's up to.
What is the difference group and sum? What is the difference between it? Because this group
Group means no, sorry.
So
No. Group means that you must mark those attributes which are using for grouping. It's not group. Grouping attribute.
this is the level of aggregation, let's say. Level of
Aggregation level. You have ordering attributes and grouping attributes, and this is order and group. And we have now two statistics: sum and average. And average can be weighted average,
Yeah.
arithmetic or weighted average.
This is another example we have here that you have weighted average. So this example is weighted mean of age and just weighted per plot, and it is weighted by the age is weighted by volume. But basically, you can weight it by all the attributes in the layer. Again, we can add species or whatever. Nothing else. So this is it. But more we can regarding querying database, we can do more things in the next tool that I'm going to present in the next presentation in the next section. So are there any more questions?